Okay, so we determined we had lambda equal to 0, we had lambda equals to 2, lambda equal to 6, and if we continued, we would get lambda equals to 12, 20, 30, and so on. And so what we realize is that this quantity can be obtained in the following way with some number L, which we end up calling the orbital angular momentum quantum number. So lambda is L times L plus 1, and so L is 0, 1, 2, 3, and so on, and so we can reproduce these things. So basically, where are we? We have L squared, the L squared operator acting on the wave function gives us this L squared times psi. We can think of this as L squared acting on this thing, which we wrote as the R function times the theta function times the phi function, which looks like this. So we know the phi functions, we've explored the theta functions. This gives us the L squared R, gives us the function back, the wave function. All right, so it looks like that. This thing doesn't act on this, so this just cancels out. So this, in other words, this just goes through the R function, doesn't do anything. So L squared e to the I m phi gives us L squared theta e to the I m phi. Or we can write this as minus h bar squared, two derivatives in theta, plus the cotangent of theta, one derivative in theta, plus 1 over sine theta, two derivatives in phi on this angular part, theta phi part. That gives us L squared phi e to the I m phi. Yeah, so we already saw this is minus, minus h bar squared, two derivatives in theta, theta function, this is acting on the theta function, cotangent of theta, d theta, minus m squared theta for sine squared theta, little theta equals L squared times big theta. And basically we see that lambda, theta, big theta, and the m functions. All right, this is when this is 0, this was some constant. This was 0. This is 2. We had this was cosine or sine of theta, and m was 0 and plus minus 1. And when it's 6, we had cosine squared theta minus a third. We had sine theta times cosine theta, and sine squared theta. And here we had 0 plus minus 1 plus minus 2. And so the L squared is L times L plus 1, h bar squared, and we saw earlier that LZ is m times h bar, m times h bar, or in other words, L operator squared on the wave function gives us this quantity times the wave function itself, and similarly for the LZ, we get the m h bar times psi. And so we now need to evaluate this part. That's the remaining part of the wave function. What are those R functions like?